First term, conditional statement. If A, then B. Sometimes they write A, therefore B. For example, if I live in Toronto, red, then I live in Canada, black. First portion A is called hypothesis, second portion B is called conclusion. Now we can modify this original conditional statement. For example, we can take the first portion A and we can negate it. So it would be original A was if I live in Toronto. Then negation would be if I don't live in Toronto. Converse. Converse means you switch hypothesis and conclusion. So it will be if B, then A. If I live in Canada, then I live in Toronto. This one is obviously false. I could live in Montreal or Calgary. Next, inverse. Inverse means you take the original statement and you negate both A and B. So in our example it would be if I don't live in Toronto, then I don't live in Canada. Which is false obviously as well. Actually there are three statements here. A is a statement, B is a statement, and the whole conditional statement, if A then B, is another statement. So there are three statements here. Next, logically equivalent. Sometimes if you take a converse and it would be, let's say, original statement if is true, then converse is true. Or original statement is false, then converse is false. In this case, it will be called a logical equivalent. It means, like here, for example, M therefore N, N therefore M. And the sign for logical equivalent is this one. Sometimes they write IFFM, then N. We need to mention definitions. Definitions are normally logically equivalent to defined terms. For example, we say a rectangle with all the sides equal. So instead of repeating every time a rectangle with all the sides equal, we invent a new term, a square. So defined term square, definition rectangle with all the sides equal. These two statements, or in this case it's just a term, they are logically equivalent. Let's play more. Contrapositive. Contrapositive is very simple. Two steps. First, you do converse. First step. Second step, you do inverse. So in our case, it would be if I don't live in Canada, then I don't live in Toronto. And this statement is actually true, considering that our original statement was true. Now we need to consider here two very important laws that are used in geometry, logical laws. They are laws, so they're like theorems. They could be proven. We omit proofs here, but we just know that they can be proven. First law is, or a rule. First is a contraposition law. It says that original statement is logically equivalent to its contrapositive. The second law is saying that a converse of an original statement is logically equivalent to the inverse of the original statement. So those two laws can be used in geometry or like in common life deductions or inferences as well. And those deductions and inferences could be like valid or invalid. Let's consider a couple of examples. For example, let's say you're a detective and you know that the one who did it was tall. So you can write, if guilty, then tall. And this is a true statement because you know this for sure. And this is our original statement. Now let's say you have several suspects, and one of your suspects, Jack, he is tall. So can you say, oh, I know Jack is tall, so then he's guilty? No, that would be a false statement. So you cannot say that if tall, then guilty. False statement, and if we notice, this is a converse of our original statement. Now you have, let's say you have another, you have another suspect, Paul, and you know that Paul is short. So can you say that if short, then innocent? Yes, because you know for sure that the person who did it was tall. And if we notice, this is our contrapositive. So if our original statement was true, then contrapositive is true because they are logically equivalent. We use the law of contraposition. Now in geometry, let's say if a figure has properties of a square, then a figure has properties of a rectangle. True. Now let's consider a converse. If a figure has only properties of rectangle, does it have properties of a square? No, that's a false statement. And let's consider a contrapositive. Let's say we have a parallelogram. If a figure has just properties of a parallelogram, it obviously does not have properties of a square, so it is not a square. And this is a true statement.